here to router 1. Again, this is performed under the area border router. In this case, router 1 is the area border router for area 10. So we'll go under router 1 here, and we'll go ahead and do we'll go into router OSPF 1, and then we'll go ahead and do a area, and then specified by the area here, which is 10, and then we'll pronounce it a stub. So as you can see, the OSPF neighbor adjacency is down. And what we have to remember with OSPF, in order for neighbor adjacencies to form, all routers within the area have to have the same credentials. There's a list of credentials. One of them, being the stub flag. And in this case, router 1 has the stub flag set. However, router 10 does not. So what we're going to see here is that the neighbor adjacency will never form. And what this is going to basically tell us is that we need router 10 to be set as a stub as well, and any other router within the area. So we'll go to router 10. We'll go under router OSPF 1 here, and we will do a area 10 and then stub. So we should see our adjacency come back here any second. As you can see now, we have our neighbor adjacency back with router 1. So if I go to router 10 now and just take a look at the the OSPF database by doing a show IP OSPF database, as you can see, the difference here, big difference from what we saw earlier, is that we are not receiving LSA type 4s, which are again originated by the ABR, which is router 1 in this case, in area 10, and it's just telling us, informing us of where the autonomous system boundary router or the ASBR router is. So we're not receiving LSA type 4 anymore, and we're also not seeing external LSAs, which is LSA type 5 for external routes. The other big difference is that you can see here with our LSA type 3, our summaries, is that we're now seeing a default route propagated into the OSPF domain. So I can also see this default route if you just look at the routing table and do a show IP route, as you see here indicated by the OIA here. This is telling us